Let's prove this limit. The limit of the rational function x cubed minus 4 all over x squared plus 1 as x approaches to 2 is equal to 4/5. We're going to apply here the limit laws in our calculus classes. Yes, this is true. But here, since we are to prove that, we need to show the proof of this using the definition. The definition starts with these statements. I might be removing some of the starting statements, but I'm going to write here the needed statements for our proof. For every epsilon greater than 0, there exists a delta greater than 0 such that if x is an element of A is a subset of R, and where we can come up with C being the cluster point of, and here is C. Okay, you would see the correct, the complete definition of this in one of our videos as well. So less than delta, then the absolute value of f of x minus L is less than epsilon. We would like to show this using this limit, but first we will construct the existence of a delta, because if we cannot, then we cannot move forward, as delta is a very important aspect here. Now, for our limit, you have x cubed minus 4 over x squared plus 1 as x approaches to 2 equal to 4/5. This is our C. To be guided with this, as part of our process later on, we hope to see x minus 2 as it is less than delta later on to come up with the correct interpretation or representation for our delta. This is our f of x, and this is our L. So for working backwards, we would like to have this final form. We can have this scratch work here to see our target. And of course, at the same time, will help us identify the representation of delta for the requirement of existence of delta. So by substitution, this is x cubed minus 4 over x squared plus 1 minus 4/5, still less than epsilon. I might be removing this later. I'm just going to simplify this, but whatever the results here will always be less than epsilon. So as we simplify that, that's 5 times x cubed minus 4 times x squared plus 1 all over 5 times x squared plus 1 here less than epsilon. Okay, now moving forward, I might also be needing additional space here, so please be guided with that. You will have here 5x cubed minus 20 minus 4x squared minus 4. Okay, this is the result all over. Let's not multiply the factors of our denominator just for the purpose of our discussion here. Let's have it like this. So we are going to simplify this further, and our goal is to really come up with x minus 2. Hopefully we could come up with x minus 2 later. So what happens here is our numerator will have 5x cubed minus 4x squared minus 24 all over 5 times x squared plus 1 here. Our numerator could be factored with this x minus 2 and 5x squared plus 6x plus 12. Sorry for not showing that, but we can factor that here. 5 and then x squared plus 1. And as you can see, x minus 2 is already existing here. This is our intended, one of the intended parts here. So we are guided with that, and as we continue, we can have here the absolute value of x minus 2 times the absolute value of 5x squared plus 6x plus 12 all over the absolute value of 5 times x squared plus 1 here. So this is already appearing here. This is all less than epsilon. But we need to emphasize that this these two should also be represented in terms of x minus 2. And how can we do that? Okay, so we need to do that step by step. Because this is too complicated, let us assume, okay, we restrict here x be between 1 and 3. This is okay because our intended value of x here is 2. So we are actually picking the next integers in between. So we are restricting that. Now, after restricting this, we are going to assume a certain maximum value for this expression. How would be maximum? when could a fraction be maximum? That would mean it's maximum if this is large and this is small. This is very small and this is very large. In terms of this, we'll be substituting this on our denominator to keep this small. And to keep this value smaller, and this to our numerator to make this bigger, so that we could actually look into the maximum possible value of our fraction. 5x, absolute value of 5x squared plus 6x plus 12 over the absolute value of 5 and times x squared plus 1. Okay, so with this, the maximum possible value of this, when 3 is substituted in our numerator, this is 9 times 5, that's 45. 3 times 6 is 18, and then you have here 12. Okay, and our denominator using 1, so that this would be really large, because if we're going to use a 3, it will still not be the larger value. So you will have here 1, so 5 times 2, you will have here 10. In short, this is actually bounded, can be bounded as really strict. By the way, this is boundary, less than or equal to the result of our numerator, which is 75 over 10, or equal to 15 halves. This is the restriction that we could come up with our given expression here when x is between 1 and 3, because still the limit is approaching to 2, so we will have these possible values for our item. Looking into that, since we have this form here earlier, you will have here absolute value of x minus 2 times now the result of this 15 halves, still be less than epsilon. Okay? In short, x minus 2 can be expressed as twice epsilon over 15. That's twice epsilon over 15. This would be the final form of the value which is greater than x minus 2, absolute value of x minus 2, which is also similar to this. The value greater than absolute value of x minus 2 is delta. So this is what we consider as the delta. So let delta be twice epsilon over 15. Since epsilon is now existing, we can now start with our proof. Proof, we start with this. Let epsilon be greater than 0, and we assume that our delta is equal to twice epsilon over 15. Okay? And then, all of this will come into order. You will have here, again, this form, x minus c greater than 0 is less than delta. Or, you could also try here 2. You could have here x minus 2 is less than twice epsilon over 15. We have the absolute value of fx minus L is equal to what final expression? Probably this. You can try what final expression would you want? Probably this here. You will have here the absolute value of x minus 2 times the absolute value of 5x squared plus 6x plus 12 all over the absolute value of 5 times x squared plus 1, which further was simplified into less than or equal to, because this is 15 halves. So you have here absolute value of x minus 2 times 15 halves. And what was x minus 2? This is less than delta, assumed to be twice epsilon over 15. So you have here twice epsilon over 15 times 15 halves, which will give us epsilon. Finally, so we have that. We're able to establish that. Let me move all of this here, so that we could come up with our final statement. Hence, the absolute value of fx minus L less than epsilon. Since epsilon greater than 0 is arbitrary, then we conclude that here comes the limit. The limit of, I don't have much space. Let me again copy this and probably, copy that. Probably make it smaller. Let's make it small. Okay, just like that. So you will have here the limit of our given function x cubed minus 4 over x squared plus 1 as x approaches to 2. Okay, is equal to our final limit, which is 4/5. So we are done establishing the proof of this. And take note, the idea of restriction was introduced here because this is too complicated. I will give you another example similar to this where we will be able to practice this process. Thank you very much for watching.